Today we're going to be working on solving exponential equations without using a logarithm, and these are called your elementary cases. So first thing we want to do is that you might have this setup where you have your variable in your exponent and you're asked to solve. Now, if you're asked to solve, our go-to is to get your bases to match. So in order to do so, right, taking a look at this 4, can this 4 be made into a base of 2? Now, what I mean by that is if we have 2 to the x plus 6 is equal to, right? Instead of saying 4, we could say 2 to the what power is then equal to 4? Well, 2 to the squared, so 2 to the 2 is equal to 4, right? That is just another way to say that this is actually going to be 4. So now once your bases match, because our goal is to get these bases to be the exact same, then we can go ahead and ignore these bases and we're left with kind of a linear equation. Now we want to solve for your x. So get x alone by subtracting 6 to the other side. So x is equal to 4. Now we want to double check your answer by plugging in that 4 back into the equation. So if we have 2x plus 6 is equal to 4, now we know that x is equal to 4. We'll say 2 to the 4 plus 6. And so sorry, this is a negative 4, I should say, is equal to 4. So 2 squared is equal to 4. So 4 is equal to 4. And that is a true response. That is actually what it does equal. So we know our answer to be a correct one. Let's try it again with 2. Now keep in mind, we want to get your bases to fully match. So while yes, 2 times 8 can be equal to 16, right? We're not actually working with these bases. We want to make sure that your exponents, right, are having the same exact base. So instead, right, 16 and 8, they both can have as well a base of 2. And it's all going to come with practice of number sense in looking at, okay, it's not so much multiplying, right? But we're looking at, okay, well, what numbers can go into each other, right? Because 16, we just said, is 2 times 8, but 8 is really 2 times 4, which is then 2 times 2. So that's just saying 2 multiplied by itself 4 times can get you to the base of 16. So this equals 16. But it has its own exponent of this 3x. Same thing here with your 8, right? 8 is 2 times 4, and 4 is 2 times 2. So 8 can be made up into a base of 2, and there's 3 2's found within 8. And again, this has its own exponent of x plus 6. Now, depending on your number sense with your properties of exponent, we end up actually multiplying when it's between, or when you have a power raised to another power. So we're going to be multiplying here. So we have 2 to the 12x is equal to 2 times the 3x plus 18. Now that your base is fully matched, we can go ahead and ignore them and look at solving your x. So subtracting 3 from both sides, we're now left with 9x is equal to 18. Therefore, x is equal to 2. So this is what we believe your answer to be. Now, when we go to plug that in, we should see 16 to the 3 times 2 is equal to 8 to the 2 plus 6. So we have 16 to the 6 is equal to 8. Let's see, 2 plus that is to the 8. Now, we don't have to fully solve it out. Like if you don't have your calculator, I mean, but we did remember, okay, well, 16 is really 2 to the 4th. We have a 6 here. And this one is really 2 to the 3rd, and we have an 8 here. Well, 4 times 6 is 24, and 3 times 8 is 24. So these are both 2 to the 24th power. Oops. And they both match. So again, these are correct responses. We're just getting it set up to say, okay, well, what if we didn't have your calculator? So just in case, if you do have a calculator, I'm sure you can plug these both in and evaluate. But if not, if you're still interested in checking your work, this is one way we can solve. Let's try it again with 3. Now, I would say pause the video and try this one on your own. So again, 9 and 27, yes, 27 has a 9 in it, 9 times 3, but keep in mind what 9 can be made up into, right? 3 and 3. This is just another way to say 27 can be really written as 3 cubed, and then you have your exponent of x plus 4. And 9, right, 9 can be made up of 3 times 3, so 9 can be written as 3 squared, and its exponent, 2x. Let me go ahead and scoot this over here. And we have a power being raised to another power, so we'll multiply here. And we'll multiply on this one, but keep in mind, because it's a binomial, you have to put parentheses around the x plus 4, because it's not just 3x plus 4, because it's this whole thing that gets multiplied by that 3. So we have 3 to the 4x is equal to 3 to the 3x plus 12. Now that your bases match, your exponents are nice and simple, we can go ahead and drop those down and then start to evaluate. So subtract the 3x, you're left with x is equal to 12, a rather big number. And let's go ahead and double check. So we have 9 times 2 times 12 is equal to 27 times 12 plus 4. So we have 9 times 24 is equal to 27 to 16. And again, let's say we don't have a calculator. So we said 9 is really written as 3 times 2, or 3 raised to the second power times 24 is equal to 3 cubed times 16. Well, 2 times 24 is 48 is equal to 3 times 16. So again, 48. And so you'll clearly see that these are both matching. So therefore, we have the correct solution. Right, now let's try number 5 and 6, and maybe 5, 6, and 9. I think that would be a good amount. So 5. So you'll notice here that we now are working with a fraction. So we have 1 over 2. Now, thinking about our properties of exponents, right? If we want to make this to have just a normal base, right? If we have 1 over x to the a, if we were to raise it up into the denominator, or into the numerator, we now have a negative a. So same idea here. We can raise this 2 up into the numerator and then just give it a negative exponent. Our exponent on your 2 is originally 1. And when we raise it up, it's now going to be a negative 1. And this is raised to the x power. Now 16, we've done before. We said this is really 2 to the 4th power times 2. Simplify your exponents a little bit. 2 to the 8th. And now we can see, okay, well, your bases match. We get negative x is equal to 8. Therefore, we believe that x is equal to negative 8. Let's go ahead and plug in a negative into your exponent. So we have 1 over 2 raised to the negative 8 is equal to 16 squared. So we have, let's bring up to evaluate your negative exponent, instead of distributing it throughout, what we can do is do the keep, change, flip. So same idea here is that if it's a fraction and a negative, we're just going to flip it upside down. So we now have 2 over 1 now with a positive 16 over 2. So now we have 2 raised to the 8th power is equal to 16 squared. Well, what do we know about 16? Well, 16 is really 2 to the 4th power times 2. So we get 2 to the 8th is equal to 2 to the 8th. So again, we believe that this is the correct solution. Let's try it again with number 6 and then again with number 9. So we have 1 over 32. So this is really 32 to the negative first, because again, this had just a positive 1 down below. So when we raise it up, it's now negative. Right, so now we take a look at your bases. So for your bases, we can do probably another 2. 2 to the 5th, or negative 5 now, to the 2x is equal to 2 to the 6th power. So from here, we can say this is really 2 to the negative 10x is equal to 2 to the 6th. So now x is equal to negative 6 over 10. And we can reduce this. It just means that we, so negative 6 over 10, that is 2, nope, take away 2, that's 3 over 2. Oh, 3 over 5. So we do have a fraction as your exponent. So this is a nice one, as good as like the exercise goes. So let's go ahead and check. We have 1 over 32 raised to the 2 times negative 3 over 5 is equal to 64. So again, we're trying to check your response. So we really have 2 to the, nope, 32, and that's a negative 1, times now negative 6 over 5 is equal to 64. So putting this back into the same base, we have 2 to the negative 5 times negative 6 over 5 is equal to 2 to the 6th power. And you'll notice that these negatives are going to cancel, and the 5 above is going to cancel with the 5 below because we are multiplying 5 times 6 over 5. So they will cancel. So you're left with 2 to the 6th is equal to 2 to the 6th. So again, another correct response. All right, let's do number 9. And then I think we're going to finish this video up because I think that's enough practice for you. If you want to try it on your own, I'll see if I can find the answer key for you to practice. So you have 9 to the negative 1st power. 3x is equal to 27. So we now have 3 to the negative 2 to the 3x is equal to 3 cubed. So you have 3 to the negative 6x is equal to 3 cubed. So you have negative 6x is equal to 3. Therefore, x is equal to negative 1/2. So let's check your solution here. So you have 1 over 9 times 3 to the negative 1/2 is equal to 27. So you have 1 over 9 times negative 3 over 2 is equal to 27. Let's change your bases and raise that 9 up as we did from before. So again, this is looking at negative 2 times negative 3 over 2. Your negatives are going to cancel, and the 2 cancels with the 1 below it. So we're left with 3 cubed is equal to 3 cubed. And again, that is our correct response. So I'll go ahead and see if I can find an answer key for the leftovers. Again, if it's an x above, you're going to treat it the exact same way. This is just coming out to be just a fraction when you go ahead and look at your exponents together. Let me see if I can find the answer key to this one. And there you go. This is your answer key for the following worksheet. I do not make these worksheets. The only ones I do make is the one that says Morrissey at the top, and usually whatever we're working with.